The Internet of today forms many integral parts of our society, from the application of the World Wide Web, including various search engines, to data storage over networks. The Internet had made millions of users and also millions of uses. But the idea of data sharing and forming long-distance connections was at a point an enigma where few were sure if it was possible. The 1960s was a time of the Cold War with extreme technological and economic competition between the United States and the Soviet Union. The launch of the Sputnik 1 into the Earth's atmosphere by the Soviet Union in 1957 prompted the United States to fund agencies for technological research such as NASA. One of these agencies was ARPA, the Advanced Research Project Agency. Forming in 1958, ARPA was a branch of the military that developed top-secret weapons and systems during the Cold War. In 1962, ARPA invested into command and control research to improve military computers. The project was led by Joseph Carl Rubnik Licklider, with a combined background in engineering studies and physiological psychology. Licklider brought unique perspectives to the idea of a computer. At the time, computers could only process and work on one thing at a time. This process is known as batch processing. Programming in early computers led to many bugs, and scientists needed to explore new ways to make computers work. The scientists began making the computers wirelessly controlled in order to minimize the amount of time it took to process information. Licklider believes that computers are technologically advanced enough that multiple processes and the reality of time sharing is possible. In his 1960s paper, Man-Computer Symbiosis, Licklider suggests that the operations that fill most of the time allegedly devoted to technical thinking are operations that can be performed more efficiently by machines than by men. This includes mechanical work such as searching, calculating, plotting, and transforming. This unprecedented idea would influence the direction of the research team towards unexplored grounds. This was shown when he shifted the contracts of the department from independent corporations to more forward-thinking ones. In his interview, he stated, "The corporation was based on batch processing, and while I was interested in a new way of doing things, the corporations were studying how to make improvements in the way things were done already." By 1969, ARPANET was established in Montesuport, with 4 locations that hosted IMPs to the network: UCLA, SRI, UCSB, and Utah. The ARPANET developed using a new concept for data transmission called packet switching. Packet switching is when a large piece of information is divided into suitable sized blocks and are sent separately. The packets may travel through different mediums, but are reassembled to the receiver the same way it was sent. The concept of packet switching was first developed by Leonard Kleinrock in his 1961 paper on packet switching. Like Licklider with his ideas, Kleinrock was able to influence his ideas on the development of the ARPANET by his stress on the feasibility of communications using packets rather than circuits. Ultimately, the first node of ARPANET was constructed based on this idea at UCLA, when the first instance of connection between 2 IMPs in which the letters L and O were transmitted before the system crashed. It didn't matter that the computer crashed, partly because the programmers were able to identify the error and fix it for full second transmission. But the mere fact that information was transferred spontaneously would signal the birth of the Internet, and the signal and exploration in data transfer and connections. Yet the world knew little of what just occurred. In 1972, ARPANET was first demonstrated to the public in the Conference on Computer Communications. The demonstration was using this interconnecting network to send a rising application, the electronic mail. This encounter was met with massive success, while the main goal of ARPANET was not courier service through electronic mail. It ultimately accounted for most of its traffic by 1971. Through its release to the public, ARPANET found new uses outside of its military roots. It was used as a way of communication with colleagues and as a tool that supports collaboration. This usage of ARPANET grew as a result. The ARPANET began operations in 1969 with 4 nodes, the software that runs the IMPs, and by 1989 grew to over 69,000 nodes stationed worldwide. The popularity and usage of the program grew at such an exponential rate that by mid-1970s, ARPANET needed to be connected to other networks. This led to reworking of various control protocols to allow ARPANET to take in these new networks. What it ultimately led to was the creation of community networks. The X.25 protocol, which enabled communication through their service in exchange for a monthly fee, BitNet, connected IBM machines, and CSNet, connecting computers in the computer science research community. The introduction of ARPANET to the public created an exchange in innovation, and an innovation that was global in scale. The networking created by ARPANET has allowed a global exchange of information and immortalized its development. Larry Robert, in his paper, The Evolution of Packet Switching, said since the ARPANET was a public project connecting many universities and research institutions, the implementation and performance detailed were widely published. This open network of communication allowed the continuous innovation of ARPANET over a wide range of research sites. The development of ARPANET in itself was also an exchange of expertise among research. Bernie Costell, researcher at No1, has the necessary expertise and vision to figure any of this out on their own. The cultures among the early groups were very difficult. Multics, Sigma 7, IBM, @RAND. The pie-in-the-sky applications reigned over a wide landscape, with no one knowing quite where it would lead. Some kind of free, cross-cultural info idea exchange had to happen. The exchange that occurred ultimately led to TCP, which assimilated the preferences of the OSI reference model and gave way to TCP/IP protocol, standard that guaranteed compatibility between networks and finally merged them, creating the Internet. When ARPANET was retired in February 1990, few people noticed the cycle of exchange had innovated global networking to beyond ARPANET itself. The encounter of ARPANET with the general population changed the goal and outlook of the system completely. ARPA was a branch of the military, yet ARPANET could not be considered entirely a military technology. While the ARPANET did provide military benefits such as actually being able to communicate under nuclear attack so quickly and efficiently, the technology developed by scientists became a huge commercial concept that quickly took a turn away from just military use. In 1963, when JCR Liquiders assembled a team of specialists to command and control research, he prophetically called the project the Intergalactic Network. The advent of the ARPANET did just that. It created a spirit of community among interconnecting networks where people interacted and conducted activities, all in an interconnected network. Thus, it was no surprise that in the ARPANET completion report published by Bolt, Burnett, and Newman, stated that it is somewhat fitting to end on the note that ARPANET program has had a strong and direct feedback into the support and strength of computer science, from which the network itself sprung.